If you want to design detailed 3D printed car parts, you're eventually going to need a 3D scanner. So you're probably wondering, can you use the iPhone in your pocket, or should you throw down the extra cash and buy a professional 3D scanner? Well, let's test both of them and find out. So I actually have the perfect first part to scan, and it's this old ashtray insert. So having a 3D scan of this is going to work perfect to then take that and come up with a completely new design. For our first part, we'll be using an iPhone 14 Pro. You can get a 3D scan with the LiDAR sensor or even by taking photos of your part, but you can also use the front infrared camera to get a scan too. We'll also be using the Metro Y Pro, an industrial-grade 3D scanner that Revopoint sent us. It even comes with the auto turntable with pre-installed markers. The scanner is handheld and has a multi-line laser and full-field structured light scanner. It also comes with an RGB camera, along with a few other modes which you can toggle directly from the scanner. The kit includes a rechargeable battery, a mount, and extra cables, along with a calibration board too. So to scan with the iPhone, you're gonna need a couple of third-party apps. One is Polycam, which uses the camera or LiDAR sensor to run the scans. And then the second scan, which is SureScan 3D, which uses the front infrared camera to do the scans. Now on the Metro Y Pro, you have a couple of options to do the scan. One is by attaching a USB cord from the scanner to a laptop. The second way is by just ditching that and using the built-in wireless from this guy to your laptop. And then there's even a third way, which is being able to attach your phone to the scanner with a mount. That way you can actually see the scan in real time from the phone without having to look at it on the PC. We're going to start our test with Polyscan by using a LiDAR sensor. But I quickly learned that LiDAR doesn't really work for smaller parts. It's more suitable for scanning larger areas like rooms. So I turned to the photogrammetry mode in Polyscan next. It works by having you take a few different pictures from different angles, then Polyscan processes the photos using AI to create the final scan. Next up was SureScan 3D, which is an app that lets you use the front IR scanner that's used to unlock phones with facial recognition. But I couldn't see what I was scanning, so after repositioning myself, I was able to get a pretty decent scan. Now we're going to use the Metro Y Pro connected to the battery pack for wireless scanning directly to our laptop. But before we start the scan, we need to place these tracking dots down. That way the scan knows the position of the part while we're performing the scan. Then I fired up the scan using the 34 Blue Cross layer line mode, which helped complete the scan in just around a minute. Okay, so it looks like the iPhone didn't get all of the detail that I was looking for, but on the other hand, the Metro Y Pro got tons of detail. But because we're going to be using these as a reference in CAD to design an insert, I'm going to take both of them and see if we can rebuild the part with either of the scans. Here's a scan from SureScan 3D using the IR sensor I imported into Shaper 3D. First, I created the basic shape to match the scan as best I could. I couldn't see the mounting points, but I decided to extrude the part to see how close I could get the shape from the scan. And after a bit of tweaking, it looks pretty close. Once finished, I was able to export the part as an STL we could then send to the 3D printer. The next imported scan was from Polycam. The scan was much cleaner and creating the initial sketch was much easier. I was also able to create the mount points from the scan too. So I used the mirror function and extruded the part. And if you want to learn how to reverse engineer your scans in Shaper 3D, I have an entire workshop that I'll leave in the description, along with all the 3D scanning hardware too. And before we export the scan from the Metro Y Pro into Shaper 3D, I use the one-click process in the Revopoint Metro software, which automatically converts the cloud points or small points captured by the scan into a mesh. From there, I was able to delete the part of the scan like the garage floor, and I also selected the part that I wanted and used the invert selection to delete even more of the scan that I didn't need. I was also able to simplify the scan to reduce the file size before exporting it as an STL. The scan from the Metro Y Pro was the cleanest, and I was able to make a sketch pretty easy along with the mount points too. Making modifications to the size was also much easier due to having such a clean scan. Now all that's left is to print the scans from the STLs. The size of the scan from the Polyscan wasn't very accurate, but after loading the STLs from the IR scan in the Metro Y Pro, I was able to scale the STL from the Polyscan down to the right size. I also flipped the parts around with the mounts to prevent having to print any supports, and I'm also printing the parts in PETG, as these are just prototypes to test the fitment. So here are the 3 different ashtray plates that I made. These are more just for a template to maybe create something else, but the goal was to try to get the dimensions and the holes using each of the different scanning methods. So the first scanning method, unfortunately, I wasn't even able to identify the holes, and that was with the front IR scanner, and the curves didn't come out quite right just because I couldn't get enough accuracy from that IR scan, which I was kind of surprised of. Now the second came from the Polycam scan, and actually that gave a decent scan. I was actually able to identify where the screw holes were, and the angle and the round corners came pretty close. The only downside is you'd still have to go and measure the opening because the Polycam is not going to be very accurate on the measurements that it takes. So what I did is I scaled this in the slicer settings of our 3D printer to match the final one. And this is what came from the Metro Y Pro. And the dimensions are pretty accurate, and I was able to get the holes as well. And this one lined up almost exactly to the original scan. Now, typically that's how 3D scanner would work, is you're going to use it to get the measurements. A lot of the times people do think that you can just scan a part and then just print it, which is normally not the case, but why not give it a try with this next part? This time we're going to start with the Metro Y Pro using the auto turntable, and this is where the included tripod comes in pretty handy. It will keep the scanner nice and still while we capture the next part, which is an e-brake handle from the E30. And this time I'm using the 62 line blue full field structured light mode. And the cool thing about the turntable is that it connects via Bluetooth and spins automatically once you start the scan. The turntable made it super easy to perform the scan, so I tried using it with the IR scanner using SureScan 3D. But even trying to scan the part manually, I just couldn't capture the part. Next up was Polyscan, which also didn't like the turntable, so I just manually captured the pictures like I did with the previous part. Once the scan was processed and I used the one-click method in Revopoint Metro, I sent the STLs directly to the printer. Unfortunately, the scan on the phone with the front IR wasn't able to pick up the e-brake handle, but Polycam actually came up with this. It's pretty close, but you can see a lot of the triangles that are formed because there really isn't a smoothing function once you export from the Polycam. And again, the other thing is you have to remeasure your part. So here's the original, and you have to basically make sure that you scale this up to the right dimensions. And this is a comparison of the Polycam versus the original part. Okay, so here's how the Metro Y Pro scan came out, directly sent to the printer after exported as an STL. Take a look at that. It is nearly identical. So here's the original. Looks pretty good. And just to show you a comparison between the Polycam and the Metro Y Pro scan, I mean, you could probably get away with the Polycam if you enabled fuzzy skin in your 3D printer, and that would take away some of the jaggedness of this part. So even though we can scan to print these parts, that's not necessarily something you would always do, because you would still need to do things like put the hole or hollow out that part for these as well. And you can do that in Shaper 3D. We have a whole workshop that will show you how to do that, and I'll leave the link in the description below. But I do want to see how much detail we can actually grab from the Metro Y Pro. So I have the perfect next part. The next part is this bezel, which I'm going to remake for a friend, but without some of the HVAC buttons. And instead of using the cross-line mode, I'm using the parallel lines, which reduces some of the noise to help capture a more detailed scan. But I forgot to charge the battery, so I switched over to the USB cable, but I couldn't really tell any difference between Wi-Fi or USB mode. But I wanted to try something even bigger, and that's where these magnetic markers come in. Revopoint has a kit that comes with different shapes and sizes that will help keep track of scanning much larger parts, like an entire engine bay. And the great thing is you can just move these around without having to worry about using any sort of stickers. For this larger scan, I used the global tracking marker feature, which lets you scan and track all the markers before starting the full scan. And I also loaded up Revomirror on my iPhone. This lets us use the phone mount, which then connects via Wi-Fi and allows us to perform the scan with a remote viewing display from our laptop. With the markers already tracked, the cross-line scan mode picked up scans much quicker. Using the toggle button on the scanner, I was also able to scan the full details of the mount using the parallel line mode too. The Metro Y Pro also has a single line mode, which helped pick up even more detail in hard to reach areas around the bottom of the mount. Then I threw the markers on the other side of the engine bay and grabbed the rest of the scan. The only downside is larger scans do take more processing power and memory to perform a quick edit, which can take a few minutes. But Revo Metro also supports GPU acceleration if you're running supported hardware. And since this was a larger area, I decided to go back to Polycam and perform a LiDAR scan. It looked like it was working pretty well, but the scan was pretty much unusable. So I switched back to taking pictures and having Polyscan stitch them all together. And here's the final results. It looks like the app lost tracking, but the details are definitely a night and day difference between the Metro Y Pro. So after testing both the phone and the Metro Y Pro, even though you can get some somewhat decent scans with the Polycam, it's just something that I probably wouldn't use day to day. One, it doesn't pick up all of the details that I sometimes would need for car parts, and you still have to do manual measurements to make sure that you have the scales correct. On the other hand, the Metro Y Pro just has tons of different options for scanning your parts, anything from small to medium to even full-size engine bays or full-size car panels. So now you're probably wondering, how much is all this gonna cost? So if you did go with the phone, let's just go with the cheapest iPhone you can get, the latest model that just came out. It does have the IR scanner. That'll cost you around $700. So Polycam will run you $29.95 a month or $149 a year. If you want to try to use the IR scan for certain parts, that will cost you $19.99 a month or $199 a year. Now, let's just say you get both of those applications and you just get them for the year to be a bit flexible on giving you the different options. That's gonna be a total of around $950 if you wanna try to do scans with your phone. Now, the Metro Y Pro for a professional scanner that can do all the different scanning methods, it's around $1,800, but they do run specials from time to time, which I'll leave a link to in the video description below. But if you want to learn more about designing and 3D printing more car parts, watch this next video right here.